Hello everybody, today we'll be going over a probabilities problem at the IB Math Studies level, and in this case we're going to have a tree diagram. So the problem gives us that we have Sarah that regularly flies from Geneva to London, and she takes either a direct flight or a non-direct flight that goes via Amsterdam. And then we have a set of information. For example, if she takes a direct flight, the probability that her baggage does not arrive in London is 0.01. If she takes a non-direct flight, the probability that her baggage arrives in London is 0.95, which is here, and the probability that she takes a non-direct flight is 0.2, right? And so for part A, we need to complete the tree diagram. Now, before we go fully into the tree diagram, I want to talk a little bit about what tree diagrams are and what they represent. And so whenever you have a tree diagram, these are showing you different possibilities for a set of events, right? And so in this scenario, we have whether she takes a direct flight or an indirect flight. And the most important thing you have to know is that in each of these little like separations or the roots of the tree, because it's a tree diagram, the probability has to add up to 1. So for example here, this between this one and this one, I have to have 100%, right? Or 1. This scenario we're going to talk about 1 because 0.95, for example, makes reference to 95%. Okay? And so that includes this set of nodes, that set of, this set, that set, this set, and even this set. All of these have to add up to 1. And so just looking at the tree diagram in the beginning, if here I have 0.2, then I know that here has to be something that adds up to 1. And so if I put x here, I'm going to have that 0.2 plus x equals 1. And doing a little bit of math, I end up with x being equal to 0.8. Okay, so that is the main idea of the tree diagram and the most important part. And so that being shown, I'm going to do the rest of the problem relatively fast. But this right here that I just showed is the important part on how to approach tree diagrams, okay? And so having that in mind, this number here is going to be 0.8. If this number here is 0.95, then I know that this number down here has to be 0.05 because it's what makes it add up to 1. And if I have that, if she takes a direct flight, the probability that her baggage does not arrive in London is 0.01, which would be here 0.01. Then I know that the one up here is 0.99. Okay? And so that being said, I completed the tree diagram, and now we move on to part B. And now moving on to part B, we need to find the probability that Sarah's baggage arrives in London. And very common mistakes here would be doing stuff like just leaving this as an answer, or maybe adding this one and this one, or variations of that. What you're actually supposed to do is that we need to find the two scenarios where her baggage arrives in London, right? The first scenario, which is marked in red, is this one. She takes a direct flight, and then her baggage arrives. The second alternative, also in red, is that she takes a non-direct flight, and then her baggage arrives. Okay? These are the two scenarios, following both arrows, of the probability that Sarah's baggage arrives in London. Okay? And so it's not enough to say, oh, 0.99 plus 0.95, because then I would be only taking into account these arrows and not the arrows in the beginning. Okay? What you're actually supposed to do is have 0.8, which makes reference to this guy, times 0.99, which makes reference to this guy. And we have to add that to 0.2, which makes reference to this guy, times 0.95, which makes reference to this guy. Okay, and the reason that you're doing this is because the 0.8 makes reference to the scenario where Sarah's baggage arrives in London when she takes a direct flight. The 0.2 makes a reference to when Sarah's baggage arrives in London when she takes an indirect flight. And in this way, we are taking both scenarios into account, right? And the 0.99 and 0.95 are respective to each of the cases. Working this out a little bit, in the direct flight scenario, we end up with a probability of 0.792, and in the indirect scenario, we end up with a probability of 0.19. We add both of these, and we end up with 0.982, which is the same to say 98.2%. And so that is how you find the probability that Sarah's baggage arrives in London. Hey guys, you know I like to put the answer key at the end, and I wanted to talk a little bit about probabilities when you multiply and when you add them. And the simple way to look at it is that when we talk about probabilities that have the word and in them, we are going to multiply, okay? And when we have probabilities with the word or in them, we go ahead and add, okay? So having that in mind for part B, when we did 0.8 times 0.99, I mean, the probability we're trying to find is when her baggage arrives in London. And the two scenarios is first, it was a direct flight and the baggage arrived, or when it's a non-direct flight and the baggage arrives. And so listen to what I just said and how I formed the sentences, and there you will see the and or the or, and mathematically you also see it over here. Okay, so I thought it was going to be worth mentioning it when you multiply and when you add. Another way to look at the multiplying part is that whenever you have an event that depends on another one, for example, the baggage arriving depends on it being a direct flight, then we will be multiplying, right? Because we don't arrive at the baggage. The baggage doesn't arrive immediately. First, we have to see whether it's a direct flight or not. And finally, my last comment is that sometimes it's hard to tell um, which path my arrows should be taking, right? And so one way to do it is to look at the end result. The end result that we want is when the baggage arrives. And so we circle the places in the tree diagram where the baggage is arriving, and we work backwards. And so we follow the line all the way back and see where it takes us, right? It takes us here and then here. In the other scenario, it takes us here and then here. And that is another way to be sure of which scenarios we are actually talking about. And so, that being said, I hope it helped. Peace.